Good morning, everybody. We are going on to our next section today for D, solving logarithmic and exponential equations. And so those are the two learning targets. I can solve logarithmic equations and I can solve exponential equations. Now, over the past couple sections in 4B and 4C, we've been doing all kinds of things with logarithms. And the reason we need to know how to do those things is to solve exponential and logarithmic equations. So it is this kind of brings those things together. We have to use both of the things from 4B and 4C to be able to solve equations that have either logarithms or exponential expressions in them. All right, let's get started. So first, we just have a little bit of review because, like I said, these are some skills we're going to use. One of the things we did in 4B was changing between logarithmic and exponential form. So remember, exponential form is b to the p power equals a. So this is an equation because it'll have an equal sign. And so the b is the base, the p is the power, and then the a is the expression it's equal to. So that's exponential form, b to the p power equals a. And logarithmic form is log base b of a is equal to p. And um, these are equivalent forms. So if the b, the p, and the a are all the same numbers, these two expressions would both be true or both be equal. So the first examples here are converting between logarithmic and exponential form. So if it's in logarithmic form, you have to change it to exponential. If it's in exponential, you have to change it to logarithmic. So we have to change the form. A couple things to remember. If we look at A, it just says log of 1,000. There's no base written. So hopefully we all remember that this is the common log. And this, if there's not a base written, it means it's a base 10 logarithm. So the base here is 10. That's the base. This is, so first of all, make sure we know what form this is in. This is obviously in logarithmic form because it literally says log right there. So this is in the form log base b of a. So the 10,000 is the a equals p. So when I change it, if it's in logarithmic form, I have to change it to exponential. So exponential form will be b to the p power. So that the base is 10 because it's the common logarithm. So this would be 10 to the fourth power equals 10,000. So hopefully we remember that from 4b because that's one of the ways we can solve these equations. All right, let's look at the next one. B, it says log base 2 of 256 equals 8. So this is also in logarithmic form because it says log. So this time the base is 2. So this is in the form log base b of a equals p, since it's in the logarithmic form. So to change it to exponential form, it's going to be b to the p power equals a. So 2 to the 8th power equals 256. And again, we use that in solving equations. And C says natural log. So remember the ln stands for logarithm natural or natural log of x plus 2 equals 3. This is again, a special one. If you see a natural log, it means the base is e. So here, even though it's not written, our base is e. So this is an ln, or a natural logarithm, is still logarithmic form because it's natural logarithm. So it still has a logarithm. So this is in the form log base b of a equals p. So when I change it to exponential form, b to the p power is going to be e to the third power. B to the p power equals a. So equals x plus 2. Okay, so those three were in logarithmic form. We had to change them to exponential. If we look at B, This one is 3 to the 4th power equals 81. That one is in exponential form. The way I know it's in exponential form is it has a base and it has an exponent. So this is the b to the p power equals a. So if it's in exponential form, we have to change it to logarithmic form. So logarithmic form, this would change to log base b, so log base 3 of a, so of 81 equals p, equals 4. So in logarithmic form, that would be log base 3 of 81 equals 4. Okay, E, we have 10 to the x power equals 27. This, again, is exponential because there is a base and a power. So the base is 10 and the power is x. So this other side is a. So it's in exponential form, which means we have to change it to logarithmic form. So in logarithmic form, we would write log base b of a, so log base 10 of 27, equals p, which is x. Now this one says log base 10 of 27. So again, this is one of our special ones. This is a common logarithm. The common logarithm is a base 10 logarithm. When we see that, we don't really have to write the 10 in. So the way we would see this written would be just log of 27 equals x. And that, of course, means it's a base 10 logarithm, but we don't have to write the base 10 when it's a common logarithm. All right, and F, we have e to the x plus 3 power equals 18. So notice I just said e to the x plus 3 power. So this has a base and a power, which means it is exponential. So if it's exponential, I'm going to have to change it to logarithmic form. So this time the base is e, the x plus 3, that whole expression is the power, and then the 18 is the a. So when I change it to logarithmic form, it's going to be log base b of a, so log base e of 18 equals p, so equals x plus 3. Now again, this is one of our special ones. We would never see it written as log base e. Any logarithm with a base e is the natural logarithm. So instead of writing log base e, we would write that as natural logarithm, or ln. So the way we would want to write this is natural log of 18 equals x plus 3. Okay, so that's one of the strategies we can use if we're solving logarithmic and exponential equations. So if you feel comfortable with that, you can use that strategy. The other thing we can use, we also did this, these are using properties of logarithms. I think we did these ones in 4C. These are some of the basic properties. So this one says if we have log base b of b to the m power. So we have a logarithm, and then we have the logarithm of a base and an exponent. Notice though the logarithmic base and the exponential base are the same. So the property that we learned with these says if we have log base b of b to the m power, where the bases are the same, the bases, the logarithmic base b and the exponential base b, get rid of each other, and we would just be left with m. Same thing applies on this one. We have b to the log base b of m power, an exponential base b and a logarithmic base b. The base and the logarithm will get rid of each other, and we'll just be left with m. So this is another strategy we can use to solve equations. So let's look at these ones. So on A, we have log base 2 of 2 to the 8th power. We have a logarithmic base of 2 and an exponential base of 2. The log base 2 and the exponential base 2 get rid of each other, and all that's left is the 8. On B, we have log base 4 of 4 to the x plus 5 power. Again, the log base 4 and the exponential base 4 get rid of each other, and all that's left is x plus 5. This is true because remember, logarithmic expressions and exponential expressions are inverses of each other. All right, C. This time we have we have 6 for the log base 6 of 24. And so we have exponential base 6 and a log base 6. Those get rid of each other, and we're just left with 24. And D, we have e to the log base e of 5x plus 3. So again, an e and a log base e would get rid of each other, and we would just be left with the 5x plus 3. Now, one thing to keep in mind on this one, the way it's written here is e to the log base e power, so we could see that those are the same, but remember, we don't write it as log base e. The way we would actually see this would be e to the natural log of 5x plus 3 power. So you have to remember that a natural log has a base of e, so an e and a natural log still get rid of each other. So like I said, we use all those properties when we are solving equations. So let's solve some equations. Today we are going to solve logarithmic equations. So here's our steps. So step 1, we want to isolate the logarithm. So the logarithm needs to be by itself on one side of the equal sign. So we need it to be in the form log base b of a equals p. So then step 2, there's actually 2 ways to solve these. That's why we reviewed 2 different properties. One, you can change to exponential form. So if an equation is in logarithmic form, you can change it to exponential form. Or you can do what's called exponentiate both sides. So this word, exponentiate, means we're going to use both sides of the equal sign. Use both sides of equal sign as an exponent to the same base. So step 2, exponentiate both sides, which means use both sides of the equal sign as an exponent to the same base. And of course, I'll show you what that looks like in a minute. All right, then number 3, step 3, we then should be able to solve for x. And lastly, we need to check for extraneous solutions. Check for extraneous solutions. So remember that we can't take a logarithm of a negative number. So the expression we're taking the logarithm for, a, that's what we're talking about here, a must be positive. So the expression we're taking the logarithm of must be positive. And if it's not, then there's an extraneous solution, or that solution doesn't work. All right, so let's look at some examples. So number 1 says log base 4 of 3x plus 7 equals 2. So number 1, the logarithm is already by itself. There's nothing else outside what we have of the log base b of a. So this whole thing, since it's in parentheses, is a. So it's part of the logarithm. Wrong letter. This is log base b of a equals p. So this one, step 1 is already done. We don't need to isolate. So then step 2, there's 2 ways we can do this. We can change forms, or we can exponentiate. I'm going to change forms. This one is in log form. I'm going to change to exponential form. So in exponential form, this would be 4 to the second power equals 3x plus 7. So b to the p power equals a. The reason we want to do that, the reason we want to change forms is before the a was part, or the x that we were trying to solve for was part of the logarithm, and there wasn't a way to solve for x without getting rid of the logarithm. Changing to exponential form gets rid of that logarithm. So notice there is no more logarithm in this equation. And now this side of the equal sign is just a number that we can evaluate. So now I can just keep going and evaluate this. 4 to the 16, 4 to the second power is 16. So now I have 16 equals 3x plus 7. And from here, we can just keep going. This is now just a linear equation. And now step 3 was to solve for x. So now I'm just trying to isolate the x. So to do that, I would subtract 7. So that's going to give us 9 equals 3x, and divide by 3, and we get x equals 8. Okay, so that's our solution. So we did step 3, we solved for x. We do want to think about extraneous solutions though. Just make sure if we plugged in this 3 into this equation where this x is, that we would have a logarithm of a positive number. If I plugged in a 3 here, we'd have 3 times 3 plus 7, so that would be 16. That's fine because it's positive. If it was a negative 16 or any negative number, then this number wouldn't work. All right, so that's one strategy, changing from logarithmic form to exponential form. So now let's look at number 2. This one has 3 log base 2 of x plus 5 equals 8. So to solve this one, first, we are going to need to isolate the logarithm. So the logarithm is this part, log base b of a. Notice there is this 3 in front that we're going to have to get rid of before we can solve this. So step 1, remember, is to isolate. So to isolate the logarithm, to get rid of this 3, it's in front, and it's multiplied by this. There's 2 strategies. One, you can put it to the power, and then we'd have x plus 5 to the third power. That's actually going to make it harder because then later on, to get rid of the power, we're going to have to do a cube root. So rather than do that, the easiest strategy is just to divide by 3 on both sides, and then that 3 will divide out. So now we have log base 2 of x plus 5 equals 8/3. Now this 8/3, for now, I'm going to leave it as a fraction, 8/3. I don't want to put it as a decimal because it's not an exact decimal. I'd have to round it to like 2.67 or something like that. And it's best to not round to the end if possible. Their answer is more exact. All right, so that was step 1, isolate. Now, step 2, I'm going to do this in a little different way. I'm going to exponentiate. So what that means is each side of this equal sign, I'm going to write it as the exponent. And in this case, the base I'm going to use is I'm going to use base 2. Okay, so here's what that looks like. So I'm using base 2 because it's a logarithm base 2. So 2, I'm taking this whole thing and writing it in the exponent. So 2 to the log base 2 of x plus 5 equals also a base of 2 on the other side, and I'm using this as the other exponent. So 2 to the log base 2 of x plus 5 equals 2 to the 8/3 power. So that's what we mean when we say exponentiate. We're using each side of the equal sign as an exponent on the same base. And we chose the base because it was a log base 2. Now, the reason we want to do that is because this is another way to get rid of a logarithm. So those properties we used here, the 2 and the log base 2, remember those get rid of each other. So on the left side, we're just left with the x plus 5. On the right side, we have 2 to the 8/3 power. Now to get the x by itself, so step 3 is to solve for x. So to get the x by itself, we would subtract the 5 from both sides. So then we would have x equals 2 to the 8/3 power minus 5. So notice on this one, 2 to the 8/3 power is not necessarily a whole number. So this is what the answer looks like exact, but you're going to be approximating your answers so that you can enter your answers in on a Google form or something like that. If you left this exact, you could enter it in like this. The way you show a power, if you're typing it in and you can't actually do a power, you could write this as 2. Here you use this button for the power, 2 to the 8/3 power minus 5. Or like I said, we could just approximate this on our calculator. So we can use any calculator, any scientific calculator that does a power. So I'm doing 2 to the power of, so see the little caret button there, 8/3. I'm using parentheses around the 8/3 just to make sure it gets entered right. So 2 to the 8/3 power, and that equals 6.349. And then don't forget, we're still subtracting 5. So we get x is approximately 1. We'll round this to say 1.350. When we're rounding, round to at least 2 decimal places or 3. So you do want to round to 2 or 3 decimal places. If the question gives you a specific to round to, like to the hundreds place or thousands place, make sure you do that. All right, we're going to stop there. Tomorrow we'll solve more, well, not tomorrow, Monday we'll solve more logarithmic equations. Have a good weekend, everybody.